Hello everyone, welcome to the another very important session in which we will be discussing some more important questions and very important concepts for our upcoming CSIR NET and the GATE Physics exam. So guys, we are going to start the discussion about these important questions and concepts in this session, but before going ahead with the discussion, I would like to tell you something about the different subscriptions which are available on Unacademy and which will be helping you to take your preparation to a very good level. So let's go through some important slides first and then we will be starting the discussion about the important questions and concepts in this session today. So if I'm going to talk about the first slide, I'm going to show you right now here, which is regarding the iconic subscription. So if you're the one like who don't want to miss the important courses and the classes by the top educators, then in that case you can take the Unacademy Iconic or Unacademy Plus subscription, and whenever you will go ahead to take the subscription you can use and apply the code that is Anjali A Live as mentioned here on the screen. Other than that, even now the notes are available on the learning app which will be helping you to take your preparation to a very good level. Along with this, even in the plus subscription, what are the benefits you will get? You can have a look at this slide to get the idea about that. Other than that, this is about the light subscription. Even if you will take the Unacademy Plus Iconic or the light subscription, you can use and apply the code that's Anjali A Live as mentioned here on the screen to get the discount in the total subscription amount. And all the benefits whichever you will get if you are going to take plus subscription or the iconic subscription or light or any other subscription, you can clearly have a look at all these benefits and that will be making everything clear to you. But still, if you will have any question or query, you can let me know, we can talk about it. Also guys, few in more slides are there. Let me just quickly show you, like this one which is regarding the Unacademy learning app. This is something about this session, this is something related to me, and then this is going to be about the community feature which will be helping you to know about the latest updates, the important information and many important things about the new courses you can get to know with the community feature. So this is how it will be helping you. So our today's session is about the nuclear and elementary particle physics. So now I need to let you know about the important questions and the concepts from nuclear and elementary particle physics, from where you can expect the questions in your upcoming exam, and what are the topics based on which the questions have been asked in the previous years. All that we will try to consider in this session right now for the nuclear and elementary particle physics portion. So for any question, if you will have any doubt or something you are not gonna know or you are not gonna relate with the concepts, I will be helping you in that case. Okay, so let me just quickly start the discussion with the first question I'm gonna consider here. And as discussed, at any point of time, if anybody will be having doubt, difficulty, or something you don't know about, you are having difficulty in solving it, we will be talking about all those parts. Okay, you can let me know about it then. Okay, let's take our first question right now, which is, like, we are gonna take the questions from different concepts and topics here. So it's not gonna be just one topic based or just two topic based. It will be from different topics, whatever are having the great chances to be there in your upcoming exam. So all are important. Some you may find quite easy, some of the questions you may find quite difficult, but everything will be important. Okay, and wherever you will have difficulty, you can let me know, we can talk about it. The first excited state of the rotational spectrum of the nucleus that is 238, uranium 92, has an energy (45 kilo electron volts) above the ground state the energy of the excited state in kilo electron volts is, options are 150 or 120, or is it gonna be 90 and 60? So first of all, I'm gonna wait for someone's reply. Like if you're gonna get to know about the final answer, you can let me know in the comments, or otherwise I'm gonna let you know about the process, the steps you have to follow, and everything you have to do. If you are not gonna get the answer, then I'll be helping you to know about the steps and how you can get the final answer for this question. So actually guys, it is the first excited state of the rotational spectrum of the nucleus, which is this nucleus. See, when you read the question till this point, you got to know it is from the rotational spectrum part, right? And the other part, when you study about the rotational spectrum, there can be two things in your mind. And most of the students can make this mistake, what I'm going to talk about right now. And what is that mistake? Can you think about it? If yes, you can mention it in the comments. And if no, I'm gonna let you know. So the thing I'm gonna talk about right now is that most of the students, when they focus on the word rotational spectrum, they think like, oh, this question is from the atomic and molecular physics because there we talk about the rotational spectrum. So they take it in a different direction, okay? Means they related it with some different subject. But as you're going to go ahead to read it, and if you're the one who will be focusing on the word nucleus, from here you should be able to get it. Oh, it's not from atomic, but it is from the nuclear and elementary particle physics. Now, the question is, does it make difference if we are relating it with the atomic or we are relating it with the nuclear? Yes, it makes a big difference. Your answer can get wrong if you relate it with the wrong subject, because the allowed J values for both of them are different. When we talk about nucleus, there are different J values. When we talk about the atomic and molecular, then we are having different J values. So that means it's very important to relate it with the right subject, even if the topic name seems to be same. Okay, so yeah, it's from nuclear and elementary particle physics, not from atomic. So if you are the one who has studied the new rotational spectrum in the atomic and molecular, and you are relating it with that, don't do that because it will be giving you wrong answer otherwise. Okay, let's go ahead. So first excited state energy in this case is what? That's going to be 45 kilo electron volts above the ground state. So this is 45 kilo electron volt above the ground state. Means this difference is 45, right? Now next thing, the energy of the excited state will be what? Which excited state? We need to mention here the second excited state, okay? Because it should be clear. Now once you got this question, let's talk about the J value here. That will be 0. And what about here? It will be 2. And what about the next one? It will be 4. Why? Because it is nuclear and elementary particle physics. So in this case, the rotational spectrum we can only observe for even J, even parity, even J, even parity, even J, even parity. Okay, so that's something which is making difference in both the subjects. Okay, now since we are, if we will find the ground state energy, what it will be? It is going to be h squared square over 2I, the normal energy expression for the rotational spectrum, J over J times J plus 1. Okay, if you will see for ground state, J value is 0, so your ground state energy is 0. But your first excited state energy was 45 kilo electron volts above that ground state. Means your first excited state, which is E2, its energy will be 45 kilo electron volts. Okay, now you have to find the E4. So the point is, if you will plug in the 45 here at place of EJ when you are working on the E2 part, so 45 is equal to what? That's going to be h square over 2I j into j plus 1, which is 2 times 3, which is 6. So your h square over 2I value from the E2 you will get, that is 45 over 6, right? Once you got this part, what next you have to do? Let me just see whether everything is all right and clear. Yeah, I think everything is fine. And we can go ahead then. Okay, if something will not be clear, you can even tell me like something is not clear and we can talk about it. Now, next thing. If we are going to talk about the next part, what is that? That is simply going to be your E4 value. So what it will be, h square to square over 2i, its value we already have, and j into j plus 1, which will be 4 times 5. And then you just have to simplify it. 2 2s are 4, 2 3s are 6, 3 1s are 3, 3 5s are 15, and then simply solve it. You can get the value of E4. Did we make some mistake? Let me just see. Like, are we getting it same? Oh, it was 2 here, right? 2. So 5 2s are 10 and 150 is our answer, because earlier I was not considering that 2. I was not able to look at that too. So in that case, I was getting 15 times 5 and I thought like, oh, it's not the answer. But when we are having 2 there, it's giving us 150. And what will be the unit? It will be kilo electron volt, because already you had this as kilo electron volts. So your answer is option A, which will be the correct one. You can tell me if in case still there is any doubt you're gonna have, we can talk about it. But if it is clear, I can give you the next question. Okay, this is what we are gonna have, right? Let's talk about it. So actually, in this case, what's going to happen? In this case, they have given us a baryon X decays by a strong interaction. Now, once you get this much information, you get to know, like in this case, the isospin will be conserved for the particular reaction, the I3 will be conserved, the hypercharge will be conserved, the straightness number will be conserved, and along with that, the other Q, B, L, all these will be conserved, right? So you get to know about these details as they give you the statement, a baryon X decays by strong interaction. So strong interaction tells you about these conservations. As X, which gives you sigma positive, pi negative and pi naught as the particles after decay, and where sigma positive is the member of isotriplet. Okay, they have even provided you that information there. The third component, I3 of the isospin of X, is what? That's the main question. So what is I3 for X? That's what you need to tell them now. You know sigma and pion, like this particle and these particles. These belong to the isotriplet families, right? Which are having the three different charge state particles in their families. So we know m is equal to 2i plus 1, right? And for the triplets, it's quite easy to allot the values of I3 as per their charge values present on them. So we can firstly find I and it will be easy for us to find the I3. So multiplicity is 3 because there are 3 family members for them. And then it's going to be I is equal to 1. Then for sigma positive, it will be +1. Same way for pi negative, because its multiplicity is same. You will get -1, and for this one, you will get 0. So when you're just gonna normally add the I3 values for the right hand side part, you will get 0, which gives you x I3 must be 0, which gives you option A is the correct one. This is how you can simply get the answer for this question. So till now you learned two different ways of solving two different concept based questions. Now here is the third one. And even if you are the one who has not prepared nuclear and elementary particle physics for the exam, but you are looking at this discussion in the session, it will surely be helping you guys, okay? Because it's very, very, very important discussion we are doing right now. Let's do it. Let's do it. If in a spontaneous alpha decay of 232 uranium 92 at rest, the total energy released in the reaction is Q, then the energy carried by the alpha particle is this is your question, and the options are 57Q over 58, Q over 57. Next one is Q over 58. And the next one is 23Q over 58. And the next one is, that's what you have to do. If in a spontaneous alpha decay, okay, of 232 uranium 92 at rest, the total energy released in the reaction is Q. This is the total energy released. Okay, so then the energy carried by the alpha particle is what? That means energy carried by the alpha particle means what? Means what? That is the kinetic energy they are asking you to consider, okay? And the energy released is what? That's the disintegration energy. So when you study about these topics, you may read or you may study the words disintegration energy, the kinetic energy, and accordingly you may have prepared the formula too. So when you consider that, you get kinetic energy of alpha particle will be equal to the A minus 4 over A times the disintegration energy Q. What is A in this case? 232. So just plug in that value. You will be getting here 228 over 232 after subtracting 4 from the numerator part times Q. So when you got this, after simplification, you will get 57Q over 58, which is your option A, and that will be your right answer. So this is how you're gonna get it. But still, if you're having any doubt anywhere, you can just tell me and I can talk about it. But if it is clear, that's great. We can take the next question and you can learn the another concept with that question too. But still, if you're the one who is gonna find like, oh, I'm still having some doubt in this part, so make sure you are gonna let me know so that I can explain you that point. Otherwise, we can go over the next one. Okay, I'm gonna write it. Give me a second. Okay, guys, it's gonna be, let ES denotes the contribution of The surface energy per nucleon in the liquid drop model the ratio ES which is for 27 aluminum 13, this is S, to ES that is 64 zinc 30 is, options are 2:3, 4:3, the next one is 5:3, and the next one is 3:2. I'm gonna wait for your reply this time, and then we will go over the next one, or the discussion of this question we will start. So it is given ES denotes the contribution of surface energy per nucleon. Now when they have said the word per nucleon, it means you have to divide it by the mass number, that is A. Okay, so surface energy ES divided by A, that's what they're asking you to consider. The ratio ES, that is this to this ratio, you have to find. So here it is very important for you to know how the surface energy depends on A, because other terms you will have is just constant. So when you know that dependency, you will be familiar with it. ES is proportional to A to the power 2/3. And when you talk about surface energy per nucleon, you divide it by A. So it gives you surface energy per nucleon is proportional to A to the power -1/3, right? Now, in this case, what will happen for aluminium and for zinc, you need to consider it. So when you will take that ratio, since the power is negative, you can take the positive power by taking the reciprocal, means 64 divided by 27 and then overall power 1/3, right? So it will give you 4/3. That means your option B is the correct answer. Then this is how you can get it. Tell me if in case there is any doubt, or if you were the one who was not familiar with the surface energy dependency on A, that is the mass number. Now you are going to get to know about it with this, and you can tell me if in case there is any doubt you are going to have at this point. We can consider that part, or we can talk about it then. But if it is clear, we'll take the next question too. That is again informative one, because it will help you to understand another formula and to know about it. For electric charge be modified for four flavors of quarks. Options are I3 plus half B plus S minus C. And option D is I3 plus half B plus S plus C. Now you can see there is just quite a little bit difference we are going to have between the different options we are having here. And we just need to select which one is the correct one as per the Gell-Mann-Nishijima formula. So if you will see the option D, where we are writing the charge expression for I3 plus half B plus S plus C. So that is going to be correct, because as per the Gell-Mann-Nishijima formula, we should have the expression same as given in option D. So you can memorize it, because sometimes you can also expect the questions based on it in the exam, as well as it can help you to find the I3, which is the third component of isospin, because this is the charge value. Q is equal to I3 plus half B plus C, B plus S plus C, right? So in this case, if you are having the information about the charge for any particle, the baryon number, the strainness number, or like the charm quantum number, basically if we talk about the I3, we don't take the charm quantum number. Okay, mostly we just consider the formula I3 plus half B plus S, while in this question they added the information about it, and that's how it has been taken. So in this case, it is going to help you to find the I3 value in most of the cases. So that's how even it is gonna be important. And here, for answer, like to answer this question, you need to know that. Okay, now let's take the another question, which is again related to a different formula and different concept. But still, if somebody is having any doubt from any of these points we have talked about till now, you can surely let me know about it, and I will try to consider those points. Okay, but if everything is getting clear, then that's great, great, great. Otherwise, if there is any doubt, you can just mention it and I'll talk about that. So here is our next question. This is since the lowest. Let me just correct it. protons and neutrons. Options are, let me just write options here. 4He2 and 1608. 2D1 and 8Be4. 4He2 and 8Be4. Option D is 4He2 and 12C6. These are the options. Now you just have to consider that what will be the right option as per the question statement. So if you will see the question statement, what they have mentioned there, let's consider it. So it is given as, let us approximate the nuclear potential in the shell model by a three-dimensional isotropic harmonic oscillator. Since the lowest two energy levels have angular momenta, L is equal to 0 and N is equal to 1 respectively, which of the following two nuclei have magic numbers of protons and neutrons? So to answer this question, since everything you have in the given options, okay, like the values and everything, but first thing you need to know is what are magic numbers and what are these numbers exactly. So it's going to be 2, 8, 20, 28, 50, 82 and 126. So you have to see in which of these cases the number of protons are 2 and the neutrons even must be matching with some of these magic numbers. So then you will say, oh, this tells you that that particular nuclei is going to be more stable. Okay. So if we are going to talk about the number of protons and neutrons equal to magic numbers, so that is in option A. If you will see, the number of proton is 2 and number of neutron is also 2, because 4 minus 2 is 2. Okay, and the other case, its number of protons 8 and number of neutrons also 8. If we will talk about the next one, that's going to be the 1D2 case, right? Number of proton 1, but which is not equal to the magic number, so it's not gonna be the right answer. Other than that, if I will talk about the option C, there are 4 number of protons which are not equal to the magic number, hence it is also not equal to the not the answer for this case. In the option D, 6 is not a magic number, so it is also not an answer. If we will talk about the option A, in that case, number of protons and number of neutrons, both in both the cases are equal to the magic numbers. Hence, your option A will be the correct one. Please let me know if in case there is any question, query or doubt you're gonna have, we can talk about it then. But if everything is clear, then that's great. So let me know if there is something not clear to you or somewhere there is doubt, we can then talk about it. But if everything is getting clear, then that's great. Okay, so what was the right answer? It's option A, which is the correct one. Let's take the another question now. Okay, it's here. The dominant interactions underlying the following processes which is, the first one is K negative plus P for proton here, and summation sigma it's negative itself. Okay, we have to just erase this sign. Okay, it's even negative plus pi positive. Then the next one is going to be mu negative plus mu positive, k negative plus k positive. The next one is sigma positive, p plus mu naught, oh sorry, pi naught, r. So options are, I'll start writing from here so that we can have everything on the same slide. Strong, electromagnetic, and the next one is weak. Strong, weak, and weak itself. Oh, is it in the option B? Yeah. What about option C? So it's going to be weak, electromagnetic, and then the next one is strong. The next one is weak, electromagnetic, and weak itself. Try it out now and let me know what will be the right answer according to you. But in case if you are gonna have any doubt anywhere, you can surely mention it and let me know about it. We can talk about that part then. And if everything is clear, then that's great. So just consider that which one is a strong, which one is weak, which one is electromagnetic in these given reactions, and what you have to check for that. Even I'll be letting you know that part. But if you already know, then that's great. We can talk about that process and we can try to consider it too. Okay, so what you need to know for this part, guys, basically in this case, you need to know that if we will talk about leptons as the particles, they don't participate in the strong interaction. Okay, which means if there are leptons present somewhere, so that cannot be with a strong interaction. Okay, so in that case, what will happen? In that case, you can consider that leptons are what? Electron, muon, tau, electroneutrino, mu neutrino, tau neutrino. So in the B reaction, the leptons are present, that is muon. So that means it cannot be possible with the strong interaction, right? And that means that it will be either with weak or electromagnetic. But what about the first one? So you can see in option A and B, and even in option, okay, or just in A and B, it has been shown that it is A will be possible with the strong interaction. So will it be possible with the strong interaction? To check it out, what we need to do, we need to check out the isospin conservation in the A reaction. So if it will be conserved, its chances for being strong or with the strong interaction will increase, right? So let's check it out if the isospin is conserved for the A reaction or no. So for the K negative, if you will consider the multiplicity for this particle, it's 2 because they exist in doublets. So it means m is equal to 2i plus 1, 2 is equal to 2i plus 1, because its multiplicity is 2, it will give you 1 over 2 as the isospin. For proton also we take the multiplicity as 2, because we consider in the nucleus proton and neutrons exist together, so its isospin will also be 1 over 2. For sigma negative, it will be 1, because its family is going to have the 3 members. It's a triplet. It is also a triplet. Its isospin is also 1. Now we need to know that the isospin will be get added as per the vector addition. So half minus half to half plus half at a gap or an interval of 1, 1 value, which will give you 0 and 1 for the left hand side and 0, 1 and 2 for the right hand side. You can see there are some common values we are going to have, and when there are common values, which means the isospin is conserved, and it means it will either be possible with the A or the B, means the given options. Okay, so in that case, options like this C reaction is given with weak in both the cases. And how we got to know it will be possible with either A or B option? Because you can see when isospin is conserved for A reaction or A interaction, it is gonna have great chances for it to be with the strong interaction. Now we just have to check for B. If the I3 will be conserved for B, you will say it is possible with electromagnetic, otherwise it will be weak. So let's check I3 directly. For leptons, if we will talk about mu negative, you know that the isospin I3 formula is what? Q is equal to I3 plus B plus S over 2. So it's not a baryon, it is a lepton. It is not having a strangeness number, that's 0. So it will have I3 is equal to what? I think you are going to get negative 1. Is it so? Are you getting negative 1 for this? And for this one you will get positive 1 then, because its charge is that. Okay. Other than that, for this one you will be able to have the strangeness number as well. So you will be having, according to that, it's negative half, and it is going to be positive half, as this is its isospin I3. Okay, not just isospin but third component of isospin. So this will give you 0 I3, this will give you 0 I3. So that means I3 is conserved, and that will be possible with the electromagnetic interaction. Hence option A is the correct option. This is how you can simply get it. But in case if there is anybody having any doubt, you can surely let me know about it and we can talk about that part. But if everything is clear, that's great, great, great. So option A for this question is correct. Let's take the next question now. The ground state this is a spin. Options are okay, let's consider it now. So actually in this case, what they have asked you to consider, the ground state of 200, like it's a lead, but I'm just gonna remove its values corresponding to this one given because they may be different too. But in the question, whatever was mentioned, I have taken that right now. The ground state of lead nucleus has spin parity, that is Jp is equal to half negative, while the first excited state has Jp is equal to 5 by 2 negative. The electromagnetic radiation emitted when the nucleus makes a transition from the first excited state to the ground state are. So actually in this case, what will happen? It's going to be the spin and parity for two states are given to you, for the ground and for the first excited state, and the transition is taking place between these two states. Okay, now in this case you need to consider that the electromagnetic radiation which will emit when the nucleus makes a transition from the first excited to the ground state. So what will be the electromagnetic radiation which will emit from it? Will it be E2 E3, M2 E3, E2 M3, or M2 M3? So for that you need to know one trick. And what is that trick? For that I can let you know a word, that is neum, 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 neum. And for no. And why for yes? For what we are doing this yes and no? It's for the parity. Basically, as you can see in the notations, positive and negative, so these are the parity. Okay, even they have written this spin and parity value. So parities, you can see negative negative given. So is the parity change taking place? No, which means you have to follow these three words right now. If it will be yes, then you will follow the next three words. Okay, now if it is no, what is the meaning of this E? It's even. And what is the meaning of the second E? It's electric. And what is the meaning of the yes part terms? So it's even. And what about this? Magnetic. So actually, if even electric is there, odd magnetic will be there. If even magnetic is there, odd electric will be there. That's what you need to know. And once you get to know about it, it will become so easy for you to work on any such type of question. So let's have a look at this part. But how to get even and odd values? That's the next question. While here it is quite easy for you to consider because everywhere in all the options they have just mentioned 2, 3, 2, 3, 2, 3 and 2, 3. So you are having the clear idea from this part. But if in case you are not gonna have this given to you and there are different values of 2, 3, except that there are different values given, then how you will decide which one is correct? So for that you have to find L, which is going to be equal to J1 minus J2 to J1 plus J2 at a gap or an interval of 1, 1 values. What will happen in that case? It's half and 5 by 2. So 5 by 2 minus half or half minus 5 by 2 doesn't matter because it is within the mod. So it will give you 2, and half plus 5 by 2, that will give you half plus 5 by 2 is 3, right? So this time no parity change is taking place. That means even electric, which means E2. Then even electric means odd magnetic. So E2 and M3 will be your final answer. That's how you're just going to get it. And that's how E2, M3, which is option C, that will be your correct option. So this was something important you need to know. And once you got to know about it, it will be easy for you to work on any such type of question in the exam. We will be taking the next question now, but in case if there is anybody having any doubt, you can surely mention it and we will try to consider that part as well. Let me just try to consider more question. Mm-hmm. Mm-hmm. I'll be writing it. Let's do this one. Match the reactions on the left with the associated interactions on the right. So the first one is pi positive, mu positive, and mu neutrino. So pion, muon, and mu neutrino. Okay. The second reaction is pi naught, which gives you gamma and gamma. The third one is pi naught plus neutron, pi negative plus proton, and you have to match them with first, second, third, which are simply going to be strong, electromagnetic, and weak. And your options which are given to you are something, something, something. I'll be writing here like this. No, 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 no. Okay, like this. It's going to be first with the third one. Second with the second one. Will you try to relate them this way, that second belongs to the second point itself? Third with the first one. Or your option B says first with the first one, second with the second one, and third with the third one. First with the second one, second with the first one, third with the third one. Option D says first with the third one, second with the first one, third with the second one. Now you just have to see which one seems to be more accurate and the correct one, because that will be your final answer then. But if you're not able to get it, I'll be helping you in that case. These are the ones you have to match. This is the slide with the given options. Let me know if in case there is any doubt you're gonna have. We can talk about it then. Let me just even tell you. You know that leptons cannot participate in the strong interaction. So first one cannot be with the strong interaction. It will be either with weak or electromagnetic. But you know presence of gamma tells you there are greater chances for it to be with the electromagnetic. Even with the conservation laws, we can check it out. Or you can directly say it here and then you can check out the conservation laws. It's up to you. So the second one seems to be belonging to the electromagnetic part. First one belonging to the weak. Then third one should belong to first one. So third with first is there in option A, and that will be the correct one because other two even are gonna be same how we have considered them. Okay, which one belongs to which one, and that's how it may be your correct answer you will have then. Okay, you can tell me like most probably your option A will be correct, and even if you are still not sure about it, you can even check it out with the conservation laws to know or to get exact 100% idea about it. While I know it like it will be the same, but still if you want to verify, you can go over that part and you can just check it out like, oh, is it correct or no? And if yes, that's great. If no, you can let me know. Okay, let's take one more question. It's here. Which one of the following three quarks quark 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 state? That's going to be Q, 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 denoted by X. Cannot be a possible baryon. The corresponding electric charge is indicated in the superscript. Options are X positive and positive, X positive, and the next one is X negative, and the next one is X negative and negative. Let's consider it now. So basically the three quark states. Okay, so you need to know there are different quarks, but their possible charges values which we are having is either plus 2 by 3 or minus 1 by 3. Okay, these are the possible values of charge we are going to have. In this case, what will happen? If you will consider the different charges they have given you. So is it possible to have plus 2 charge? Let's try to add the maximum positive charges together, Q, 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 if you will consider. And it will give you 6 over 3, which is 2. Yeah, it's positive. The 2 positive is possible. If I will take the combination of 2 by 3 positive charges and the 1 by 3 negative, so it will give you for 3 by 3, which is plus 1, is even possible. What about this? If I will take all three negative, that means all quarks are the one which are having the charge equal to negative 1 by 3. Then it will give you the negative 1, right? And it means what? It is even possible to have the negative 1. But since maximum negative charges you have already included here, and even if you will try to take any other combination of different quarks, you will not be able to get negative 2, which means option D cannot be correct, right? So that means like it's the correct answer for this question because they have mentioned uh, cannot be a possible baryon. So that's option D. Okay, that is not possible. So that is the right answer for this question. This is how simply you can answer this type of questions, guys. If in case still you are gonna have any doubt, you can let me know. But if it is getting clear, then that's great. We are gonna keep it this much right now in this session. And thank you so much everyone for joining this session till the end. Here is again the slide about the iconic subscription. We are having all the details mentioned here. And if you're the one who's going to take the subscription anytime, because in upcoming days even so many new courses will be starting on Unacademy, and so many courses are going on right now as well. So if you don't want to miss the important discussion we are doing there and we are going to consider, and you just even want to go through the important notes, so in that case all these benefits as shown here on the screen you will be getting if you will take the iconic subscription. And you just have to use and apply the code that is Anjali A Live as mentioned here on the screen to get the discount in the total subscription amount. Another one is here, which is regarding the plus subscription, and all the benefits have been shown here along with the referral code. So anytime whenever you proceed further to take any of the subscriptions, whether plus, iconic or light, you can use and apply the code Anjali A Live as mentioned here on the screen to get the discount in the total subscription amount. Thank you so much everyone for joining.